So I'm starting off the testing of the Orbi 970 by taking a Google satellite image of my house, and I've drawn in the walls, the exterior walls. This is the upstairs section. I do have a basement. Red is the outer brick wall, and then this line here indicates where in the basement I have coverage. I do not have a full basement. My basement is over here on the left. So when we go down here and look at the basement, you can see I've grayed out this area, but the basement is here. So the question you may have with the Orbi 970 is, how well does it cover in a multi-floor house and through the basement? And I'm going to show you that here in a second. But before I show you that, I want to show you how I surveyed. And I surveyed with the Ekahau Sidekick, commercial grade Wi-Fi diagnostic software with a Sidekick 2. This device has 6 radios in it. And on the 2.4 gigahertz band, it has a Wi-Fi radio and a spectrum analyzer. And it also has the same for 5 and 6 gigahertz. Here we're looking at 6 gigahertz. We can see the 6 gigahertz waveform. And then down here, this is the spectrum. This shows all the noise and all the traffic that's on there that this Ekahau Sidekick is kicking up. The areas that I walked while carrying it, you can see in the basement here. I walked inside the basement, got a lot of data. And then upstairs, I walked all the way around the house. I walked into the front yard. These green lines, you can see there's an arrow here which shows that I walked from bottom to top. And in some places, I actually stood there for about 5 seconds and took a deep dive. And when I'm walking, the Ekahau Sidekick is taking a snapshot about every 7 feet. So if I go in here, you can see these dots are where it took a snapshot of all the Wi-Fi traffic. So how did we do? Well, I want to start off by saying my house has Ruckus commercial grade 4x4 MIMO access points in it, and we're comparing almost an apples to apples comparison with the Orbi 970, which is also 4x4 MIMO. So this red means red starts with the color or the letter R, and so does Ruckus Wi-Fi access points, and you can see the name right here, Ruckus. So what I want to show you here is these access points. This is where the red Ruckus access points are located. And I put the Orbi access points as close to them as I possibly could. My fiber optic service from AT&T comes up here from the north and comes in and goes into this room. And that's where I put the Orbi router. So I've got my Orbi router connected to my AT&T gateway. And then I put the 2 satellites down here, one in the middle of the house and one on the south part of the house. This is the Orbi satellite that's in the middle of the house. So my house runs north to south. This is in the middle of the house. And this is a terrible place to put the repeater. Even though it's in the middle of the house, right next to where I put this access point, the commercial grade Ruckus 710, putting it on the floor is terrible because I know through that wall into the kitchen is where the main router is, and I need a high-speed connection there. By putting it on the floor, this wall is adding 3 dB of loss. That wall adds 3 dB of loss. Behind there is a pantry full of food, and then I need to get through that wall. The best thing that I could do is to get this thing up off the floor. And when I do that, I could put it here in the corner and get out of the way. But as you can see, to get that signal, I've got to go through that wall to get to the gateway. So I did reduce it 3 dB by getting it over this wall, which is better, but a better place to move this repeater is to move it over here. And that way I am eliminating this wall, and I have a straight shot to get to the gateway. So this satellite is on the far south end of the house, and I've put it on the floor. And I put it there because I wanted to get it close to this Ruckus AP to show you the difference in the two on 5 gigahertz. But with this being on the floor, that wall is a closet. Behind it, it's full of clothes. So there's signal degradation, and on the far end of the house is the other satellite and the gateway. If I had moved this device just over here to get it around the closet, like that, I now have cut out that wall, but I still have this cabinet over here and possibly that mirror to go through, which is causing loss, plus this extra distance. So the best thing I should do if I want the satellite on this end is to actually get it off the floor where I don't have the interference or the signal attenuation of that cabinet. So I'm going to unplug it. So let's go ahead and look at the 6 gigahertz coverage. Well, actually, I'm going to go back to the red Ruckus so you can see the difference. So Ruckus, those are R710s. They don't have 6 gigahertz, but they do have 5 gigahertz. Let's show you what it looks like. Okay, so 5 gigahertz with Ruckus. These are commercial grade access points you find in a hospital, and you can see that they have great coverage throughout the house, except this little sliver up here in the corner of the garage. And I really don't care about that. Another thing that's really important is I'm going to show you how sensitive this is. This right here in Ekahau, it says view as mobile device. So what that really means is the Ekahau Sidekick, this thing, this is a very sensitive, almost scientific grade instrument, and your smartphone is not that sensitive. It's not as sensitive as that tool. So we can come in here and show, well, this is what Ekahau sees as a measurement tool, but when I click this, this is what your smartphone actually sees. And notice that it's a lot smaller. So we're going to use the worst case scenario to look at the Orbi 970. So when you look at this, this is commercial grade Wi-Fi from Ruckus, and now at 5 gigahertz, now we're going to look at what Orbi does. And look at that. It is amazing. It's actually outperforming the Ruckus by getting 5 gigahertz into this part of the garage. I'm going to go through here and click on each individual access point. So here at the north end where the router is, that router in the north end of the house where the fiber comes in, you can see it covers the top 1/3 of the house. And the good news is it makes it to the middle router. That's really important that this middle router is in the yellow to green shadow of the main router, because then it's going to have a high backhaul link, a high-speed backhaul link. And then when I click on this one, the middle satellite, oops, that's the, there we go. You notice the middle satellite, it reaches the primary gateway access point, and it also reaches it at the south. So this is going to be an amazing relay satellite to get the south traffic up to the north, because it's got solid signal strength. The distance here is approximately 35 feet from north to the mid, and then from the mid down here it's about 25 feet. And the distance from the south to the north is about 60 feet, is what I would estimate. So then let's go look at the south access point, which is down here. This mirror is the same effect of reflecting the Wi-Fi signal back. Then I'm trying to get to the gateway, so having this mirror here is going to impact this. I've done people's houses during COVID, and we had an access point on the other side of the wall of a mirror, and it completely killed the signal on that side. So what we did was we moved the access point above the mirror, and if we're not able to do that, we actually raised the mirror. So in this particular case, I may want to raise this mirror about 6 inches so that I have a clear shot of RF through this wall to get to the router, and that way I'll have the highest backhaul signal strength that I can. So this is where the south end repeater is located, where that green tape is, and I have it laying horizontally behind the wall. It's underneath the mirror in the bathroom vanity area, so that signal doesn't get reflected by the mirror, and it's actually shooting underneath the metal back of this TV and the sound bar, and it has a clear shot over here to the satellite in the middle of the house, and it even has a direct shot right through there above the kitchen sink directly to the Orbi router. So that's a great place to put the the satellite, so that it has the maximum amount of speed and the highest power level. Or the south, and look at this. It has amazing 5 gigahertz coverage. This is absolutely amazing. Let's compare that to what the Ruckus is doing. Whoops, south. There we go. There, that's the south Ruckus, and it's doing amazingly well up against the Orbi. So that's 5 gigahertz. If we go to 6 gigahertz, this may look interesting if you don't know what to look for. So what this gray color means is at this power level where it's yellow or better means you're going to get streaming video because the power level is sufficient to support streaming video. You know, this might look like it's not enough to support streaming video throughout the house, but 6 gigahertz has 2 dB more loss than 5 gigahertz, and I've got walls in the house, and the 6 gigahertz has power limitations where it can't transmit as powerful as 5 gigahertz. So the 6 gigahertz has actually very good coverage, but because of the walls and the power level being less, it doesn't have the reach. So one of the things that we can look at is can we still use the 6 gigahertz as a backhaul? And so we go down here and you can see that the 6 gigahertz doesn't quite reach the mid access point, but let's not jump our gun. And so the middle access point at 6 gigahertz doesn't quite reach it, but they've got a really neat trick I'm going to show you here that Netgear's doing on the 970, and you can actually see the live traffic going back and forth at 6 gigahertz. So hang on, and this is the north access point. So when we're looking at 6 gigahertz, it's performing extremely well. Okay, there we go. So 6 gigahertz has really good penetration. 5 gigahertz has outrageously amazing coverage. You're going to get a lot of coverage out of the Orbi 970 at 5 gigahertz. Now, let's go look at 2.4 gigahertz. Let's go investigate. Now, the 2.4 gigahertz has amazing coverage. It's all over the backyard, and it doesn't really have much coverage in the front yard because I have the access points on purpose on the left side of this line. And the reason for that is I want the power level of the Orbis to go through the floor into the basement. I Airbnb the basement area, and I want them to have great Wi-Fi. And if I had put the access points to the right of this line, they wouldn't have good penetration. So let's go downstairs into the basement, and you can see at 2.4 gigahertz, the Orbi has amazing coverage. I mean, high power levels everywhere. We go to 5 gigahertz, it's amazing. And at 6 gigahertz, this doesn't surprise me because you do have a lot more loss through the floor. So you're probably not going to get 6 gigahertz in the floor, through the floor from the basement up, but that's okay. Hang on a second. Let's go back over here and look at the sensitivity. Now this is viewed as a mobile device, not as a desktop device like the Ekahau Sidekick or the Orbi 970. But the Orbi 970 has big antennas in it. That's why it's so big. If we turn this off, which means now we're looking at a desktop device, this is at 6 gigahertz. And look at this. The Orbi is blasting through the floor and it's going to have good coverage at 6 gigahertz. And at 5 gigahertz, it does even more amazing in 2.4. So I'm going to flip this back to mobile device. And well, let's look at the spectrum. The spectrum will be, I'm going to show you this live right here. Let me show you at 6 gigahertz first. So this is the 6 gigahertz signal, and what these are called mesas, where you can see where it comes up and looks like a mesa that you see in the desert. And right now we're looking at any SSID. I'm going to look at just the Orbi 54, which came out of the box. And you can see that there are 3 mesas here. And these are the mesas of the Orbi 970s. This low-powered one is the one farthest away on the north side of the house. I'm in the middle of the house right here, and that's the southern one right there. So you can notice that the utilization here in this area is extremely low, 1%. And when you hit 50% with Wi-Fi, you're basically saturating it. So the 6 gigahertz is extremely clean. You can see at the waterfall view here, there's hardly any traffic, virtually no noise. And then if we take this channel spectrum, if we're to flip this down, you can see that this traffic is on 6 gigahertz over there. But now let's look at 5 gigahertz. So over here, notice that I have only the Orbi 970 selected. So what it's doing over here is it is looking at, looks like channel 40. Yeah, they're on channel 40 at 160 megahertz bandwidth. And you can see there's some traffic over here. And the reason they're all on the same channel is they need to be on the same channel for multi-line operation, or excuse me, multi-link operation. And so this other traffic over here, we'll have to take a look at what that is. And I'll give you a hint. This is a secret back channel of why the Orbi 970 has 4 radios in it instead of 3. So then we're going to go down here and look at it's using 2 radios. The radio over here on the left is the Orbi 54, which your user devices are going to use. But the secret radio that it uses for backhaul is this one. It says NTGRBH. That means Netgear Backhaul, and that's the MAC address of the access points. So now notice that I have 2 mesas here, one on the left and then over here on the right. And what it's doing is I'm broadcasting the Orbi 54 to your end user devices. They are only to be using this channel. However, if I go to the secret backhaul, I have this channel, which your end user devices don't use. But we also can use backhaul at the same time for both 5 gigahertz. So that's one of the secrets that they're using is for multi-link operation, I can use 6 gigahertz, both 5 gigahertz radios, and we'll come up and explain that in a second, and the 2.4 gig radio all at the same time. And that's one of the secrets of how they're pumping so much data through there. Now, when we go look at this right here, you may think that, well, I only have 20 megahertz bandwidth when over here I've got 160 megahertz bandwidth. The reason why they're doing 20 megahertz bandwidth is notice the power level here. This power level here is about 56 dBm, but whenever you double the bandwidth, you lose 3 dB of power. So when I go from 20 megahertz, if I went to 40 megahertz, I would go from 56 down to 53, and then when I double that again to go to 80, then I would go to 49, and then before you know it, the power level goes down over here. So what Netgear is doing is on the backhaul channel, they have it narrow because the higher the power, the further the reach. So if we go look at how far is that going, we can go look at channel 157 here. And you can see channel 157 has excellent reach. And I can reach all the way to the gateway router on channel 157. And the reason for that is because they're doing 20 megahertz wide channel. But there's something really interesting that'll go on when I'm going to show you here or demonstrate in a minute here. When I start doing a speed test on this laptop, my laptop over here, it's on 6 gigahertz, and that means it's on channel 165. So this is traffic on my laptop right now, and I'm going to pull up this speed test. And I only have 300 meg service to the house because I used to have a gig, but it cost $100 more a month, and I just felt it wasn't worth it with all of the traffic that I have. So we're going to do the speed test, and now you can see all of this traffic is coming up on 6 gigahertz. But right now, at this instant, let's go down to 5 gigahertz, and you notice at 5 gigahertz, look at this. So this traffic is coming from my laptop to the 6 gigahertz Orbi, and now it's going down to the 5 gigahertz radio for backhaul. This is the backhaul channel. And let me go ahead and run that survey again. I'm sorry, that test again. So now when we go down over here, notice that I don't have any mesas to the left or the right of this main one. what the Netgear is doing is it's actually using this, but it's there's three frames. There's management, control, and data frames. And the management and control, management gets your device on and off the network. Control is the speed, but the data frames can be wider than that. So this test is showing that the Netgear has the management control frames at high power, but it uses the extended bandwidth for your data frames to get through. And it can do that both on the 6 gigahertz side and the 5 gigahertz side. What I'm going to do is a speed test using video. So I've got this laptop is connected to this video, my MacBook is on that video, iPad video, 3 videos on this laptop and 1 over here. So I'm going to, here I've got that video running. I'm going to run that video, that video, that video is now running. So now I've got these videos going and you can see the traffic. I'm going to show all the traffic here. So you can see the traffic at 6 gigahertz. So this is the 6 gigahertz traffic, and this is the 5 gigahertz traffic. And all of these devices, they are on Orbi 54. So this is all the videos that are being run. This is the backhaul traffic from the videos. And you can also see up here at 6 gigahertz, there's hardly any congestion at 6 gigahertz, plenty of airtime available. And this is even coasting. This should be red with a lot of these videos running at 5 meg per video. 2.4 gig, we know it's going to be busy, and I'll show you a way to fix that here in a second. This is one of the few comments or complaints I could have about the Orbi 970. And if you go into the dashboard and then you go to wireless, you'll see this is a very easy one. Down here, the IoT. This is for 2.4 gigahertz devices only. And you'll find that when you are using video cameras for your house or robots or anything that needs 2.4 gigahertz only, what they're really saying is it should be IoT, but something I would recommend you do is add 2.4 to this SSID when you first get this out of the box. That way it'll let you know that this is the 2.4 gigahertz only band that you should use for Internet of Things devices such as Wi-Fi cameras and whatnot. So the other thing that is shocking to me is this right here. It says auto. The reason this 2.4 gigahertz looks so bad over here is out of the box. The Orbi is on channel 8 for some reason, and the industry best practices are to use channels 1, 6, and 11. And what's happening here is because it's on channel 8, it's causing what's called adjacent channel interference, ACI, on channel 6 and channel 11. And over time, you can see it's just saturating the channel. So I'm going to go over here, and out of the box, I wish that they would come in and say, you have the option to select only 1, 6, or 11. It's industry best practices. But I know that channel 11 is the best channel. Let me go ahead and show you why. If we look at all of the SSIDs that are here in my neighborhood, this is showing all of the SSIDs. And you can see over here, I've got quite a few neighbors that are on channel 1. And I've got a few neighbors on channel 6. But over here on channel 11, I've only got one device, and that's my device. That is more than likely going to be the Ruckus, and that is, yep, that's my device. So this is the best place for the Orbi to go. So I'm going to go and provision this to go over to channel 11. And let's set this to channel 11. And 5 gigahertz channel, I'm going to leave that. This is another thing. I think that it should be using more channels than this. It's not using the DFS channels. but that's another long discussion. So let's go over here to advanced, and we go look at advanced down here, wireless settings, and over here 2.4 gigahertz band, enable 20/40. That's not best practices. I'm going to unselect that. But going back to basic here, I want this is more important. I want this on channel 11. And so we're going to hit apply. And it's going to reboot all of the devices. We're going to see a little bit of an internet drop off here for a few seconds. But then when I go over and look at this, we're going to see when I switch this down to the Netgear Orbi 54, we're eventually going to see the Orbi switch away from channel 8 when everything reboots. It'll show up over here. There, it already did. So you can see that now it's over here. And we're going to see this chart move a little bit. But this is going to actually cause less interference. And it's okay that we're having on channel 11 this amount of traffic because we've got plenty of capacity over here on the 5 gigahertz side to carry the freight. So 2.4 gigahertz, move it over to channel either 1, 6, or 11. And here you can see over here when I changed it right here, this is where it was on channel 8. And then when I moved it to channel 11, you can see over here it's cleaned things up quite a bit. Now it's still busy on channel 11, and that's okay, but it's not causing interference on channel 6 or 1. And a lot of this is just going to be management control frames, so it's going to be okay. One of the most common things that I hear from people about Wi-Fi devices is somebody in the house thinks that they're ugly and they want to hide the satellite or the access point somewhere in what turns out to be the worst possible place from a Wi-Fi perspective because they think it's ugly. But here's a really simple thing you can do. So right here I've got this Orbi underneath the mirror, which is the best place it could possibly be because the radio signal shoots under the mirror and doesn't get reflected back. Is I just have a simple painting here, and as long as it's not metal, this is not a metal frame. A metal frame's a no-no, but if I wanted to, I could cover up this Orbi with a painting or something that's a wooden frame and cover it up. That's probably the best thing you can do. You can go to a thrift store and get a frame for a couple of dollars, but if you're spending several $1,000s on an Orbi like this, and you have somebody in the house that's complaining that they don't like the looks of it, just go buy a $5 or $10 picture frame and cover it up and call it good. How hot is the Orbi? The Orbi weighs a lot because it's got two big heat sinks inside of it, and you can see right here that this one face of the Orbi, which is where the big heat sink is. Oh, there's my cat. He is supervising. Meow meow, get out of the way. Oh, there's my cat. Okay, he's the boss. Meow meow, get out of the way. This is the heat sink thermal image of the satellite that's in the middle of the house, and you can see that the front faceplate is where the big heat sink is located. It's running at about 82 degrees. I'm going to spin this around, but I got to put my hands down to do it. And here we are, we're looking at the right side, and you can see it's a little bit cooler there, but it's really not that hot. And the reason why this Orbi weighs so much is because of the heat sinks that are inside. And I'll go ahead and spin this around to the final side. And let's get a infrared image of it. Oh, look, that's really hot right there. 85 degrees, which is not that hot. This is the thermal image of the Orbi 970 router. So the red image that you see there to the left, that's the actual Orbi router, but the red image to the right over there, that's the battery backup for my PoE switches there for my Ruckus access points that are here in the house. But if we go back to focusing on the Orbi router, you can see a hot spot there is about 92 or so. So it's about the same temperature as the satellite. So I'm going to rotate this around. Let's see what the right side heat signature looks like. So there we go. About 92 degrees. And then if we look at the left side, it's, oh, maybe about 90. So the heat given off by these big access points is really not that bad.